This video is on section 8.5 notes, inequalities and systems of inequalities in two variables. So first we have just some information about inequalities. So it says graphs of inequalities have infinitely many points, which is also true of graphs of equations. What is different about inequalities is that those points, those infinitely many points that make the inequality true, can be on the line and off of the line. With a graph of an equation, those infinitely many points that would make the equation true would only be on the line. These points are represented on the curve itself or on the line itself by using a solid line, and off of the curve by shading the open space. So solutions of inequalities, if you have an inequality with a less than or equal to sign, a greater than or equal to sign, they have solutions that are on the line, and the line will be solid. That means that points that are on the line itself, if you plug them into the inequality, they will make the inequality true. Open spaces with points which made the inequality true will also be shaded. So one side of the line or the curve or the other side. Non-solutions of inequalities, you'll notice with the less than sign or a greater than sign that the points that are on the line then do not make the inequality true. And so in that case, the line will be dashed or dotted so that the person looking at the graph can say like, oh, the points that are on the line don't actually work. And then open spaces which make the inequality false will be left blank, and that way we'll know that they're not actual solutions. So here it just says to graph the linear inequalities. So we're going to graph one inequality first, and then we'll move on to systems of inequalities. So here this first inequality is written in y equals mx plus b form, and so we know we can start by just graphing the y-intercept at -3. And then the x has a coefficient of 1, it's just not written. So it has a coefficient of 1, and if we write that as a fraction, so that we can see the rise over run, that would be 1 over 1. So from this y-intercept, I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And because of the symbol, it's a greater than symbol, which means that the line itself does not have points which will make the inequality true. And so I'm going to draw a dashed line or a dotted line to show that this is where the line itself is, but that the points on the line are not true. And then we have to determine if the shading should happen on this side of the line or this side of the line to represent the other solutions to the inequality, the other points that would make the inequality true. And most people choose the point 0, 0 to plug in to check if this is true or false. And they use 0, 0 not because it's magic, but just because they're lazy and it's easiest to plug in. So I'm going to use 0, 0. And sometimes you can't. Sometimes 0, 0 is on the line, but as long as it's not on the line, you can use it. So 0 is going to be plugged in for x and plugged in for y, and I get 0 is greater than 0 minus 3. 0 is greater than -3, and that is a true statement. And so that means that this point right here represents what is true. That means the opposite side is false. And so we're going to leave this as the open space, and we're going to shade this so that we know all the solutions to the inequality are on that side. All right, here we have to graph this line written in standard form, 2x minus y equals 1. I'm not worried about the inequality right now because I just need to graph the line. So negative y is negative 2x plus 1. And I'm just isolating the y so that this would be in y equals mx plus b form. So my y-intercept is at -1, and then from there I have a slope of +2. So I'm going to go up 2, right 1, up 2, right 1. Oop. I started drawing my line without even thinking about it. So here, if you look at the symbol, The symbol says greater than or equal to, and since it's greater than or equal to, we know that the points that are on the line are actually going to be solutions to the line. And so this time it is okay to draw a solid line, because any point we plug in will be true. And again, I have to pick a point on either side of the line to figure out where the shading should be. I'm going to use 0, 0 anytime I can, just because it's easy to plug in. So 0 plugged in for x, 0 plugged in for y, and I always go back and I plug it into the original equation rather than plugging it into something that I have done computations on. So 2 times 0 minus 0 is 0. 0 is greater than or equal to 1 is false. And so this right here is false. This over here is true. And so that means we're going to shade on this side. Okay. X plus y is less than 0, so let's make sure we can graph this. So negative x plus 0, if you want to think of it that way. So this one has a y-intercept of 0 and a slope of -1, so it goes down 1, right 1, down 1, right 1, down 1, right 1. And I wanted to include at least one example where we went through 0, 0, so you couldn't use that to plug in. So here, based on our symbol, it's less than, and so we have a dotted line. And we have to figure out where to shade, but we can't use the point 0, 0. And so my typical default is I usually go for 1, 1 next, because that's also easy to plug in, but it truly doesn't matter which point you choose. So you could choose a random point. I could choose 1, 3. You can use a different point every single time, and you can always choose random numbers, and it will never matter. As long as you pick a point that is clearly on one side of the line, you will always be able to figure this out. So x coordinate, y coordinate, 1 plus 3, x plus y is less than 0. 4 is less than 0 is false. So the point that I chose was false. That means that this side over here is true. And there's my shading. All right, and then just a friendly reminder about equations like these. It means it's either a vertical line or a horizontal line. And so if I have the line y equals 3 to graph, this literally means y always equals 3, or that if you pick any point on the line, the y coordinate is always going to be 3. So you'd have the point 0, 3, 3, 3, 5, 3, -1, 3. And if you think of it like that, then you don't have to memorize if it's a horizontal line or vertical line, because it's a little bit counterintuitive. You'll always just be able to do it correctly. So we've got our points. This is less than or equal to, and so I'm going to draw a solid line. And I'll use 0, 0 again. X, y. There's no place to plug x in, so I'm only going to plug the y in. 0 is less than or equal to 3, which is a true statement. And so 0 is right here. This is true. The other side is false. And so here's where I'm shading. And you could also look at that and say, I need to shade where the y values are less than 3, and that would have been under the line. You can do that one too. That one's a little bit more intuitive. Okay, so there are the inequalities. I think the next page, the next page has nonlinear inequalities. I did make these notes myself. I just forgot what was on there. Okay, so here, We have nonlinear inequalities. So this is just going to be going back and doing some of the graphs that we have learned how to do this semester, but just doing them now with either a dotted line or a solid line, and then figuring out which side of the line to shade on. And so since we won't have a straight line, we're not going to do shade on the left or shade on the right or shade above or below. But we are going to try to determine, there's usually two sides to a curve. So we're going to have to figure out, which side of the curve we're on. So first we have a parabola. We have an x squared graph, and you might have memorized these points. You might have to go back and look at your notes. But the points for an x squared graph that we always used from the parent graph before we had transformations were these points. And since this is a quadratic that is at the parent graph, it doesn't have any transformations happening to it. It's just plug in -2, get 4, plug in -1, you get 1, plug in 0, you get 0, 1, 1, 2, 4. So if you were to square each of these x coordinates, those would be the y coordinates. And then they haven't shifted around at all. So I'm going to go ahead and graph each of these points. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And then because of the symbol, it's a greater than symbol, so I know that I should draw a dotted line to make this parabola, that the points that are on the curve itself are not solutions. And then I need to pick a point that's not on the line to determine where the shading is. And so in this case, we are going to think of the areas that we could shade as inside the parabola versus outside the parabola. So 0, 0 is usually my first choice. 1, 1 is usually my second choice. I can't go with either of those. So I'm going to go over here and plug in the 0.31 just because I see it over there. So 3 for the x coordinate, 1 for the y coordinate. So 1 is greater than 3 squared. 1 is greater than 9. That is a false statement. So the point that I chose that was outside of the parabola was false. That makes the inside of the parabola true. Okay. We're reaching back pretty far. I think this was in our first chapter where we went over this. So this equation right here is the equation of a circle. The center of the circle, because it just says x squared and y squared, the center of the circle is 0, 0. And then the radius of the circle is the square root of the number on the end. So the radius of the circle is 2. So here's the center, radius of 2. Okay, it says less than or equal to, and so that means that I'm going to be drawing a solid line to make my circle. I can try to make this actually look like a circle. Okay. And then when I do my shading, I'm either going to be shading inside the circle or outside the circle. And I can use the point 0, 0. It was the center, but the center of the circle is not actually on the line. So I can plug it in to see if it's true or false. So x coordinate, y coordinate, 0 squared plus 0 squared is less than or equal to 4. 0 is less than or equal to 4. And that is a true statement. And so the point 0, 0 is true, which means that everything outside the circle is false. And so we're going to shade inside the circle. Okay. And then last we have a logarithmic graph. So for the logarithms, I'm just going to remember where we get our points from. So we always have 1, 0, and then the base comma 1. And the vertical asymptote x equals 0. And so here, since this graph has a base of 2, it's going to be 1, 0, 2, 1. And then x equals 0 as a vertical asymptote. So I'm going to go ahead and draw the vertical asymptote in at 0. I've got the point 1, 0. I've got the point 2, 1. And then because of the symbol, it's a less than symbol. That means that I'm drawing this with a dotted line and not a solid line. So there's my graph. And so with this, I'm either going to be shading on this side of the curve, kind of to the right and down, or I'm going to be shading on this side to the curve. So I'm going to plug a point in. And I'm not going to plug in 0 because you can't take the log of 0. So I want to get a point that's actually defined. So I'm going to write that on my paper. So 0, 0 is not a good point to use. So instead, I think what I'm going to do is use the point 1, 1, because I want to make sure that I'm plugging in a point I actually know how to evaluate. So 1, 1, x coordinate, y coordinate. So 1 is less than log base 2 of 1. And if you guys remember how logs work, I'm going to write this up here because, you know, maybe you're trying to evaluate log base 2 of 1 in your head and you don't have a calculator handy. If I'm trying to figure out what log base 2 of 1 is, so I can compare it to the number 1 and see if it's bigger or smaller, I would say, well, let me go ahead and undo the log because my brain doesn't think in terms of logs. So I'd put a base of 2 on each side. And I would say 1 is equivalent to 2 to what exponent? And 1 is always a number to an exponent of 0. So 1 is equivalent to 2 to the 0 power, which means that if I had log base 2 of 1 equals question mark, that question mark was 0. So log base 2 of 1 equals 0. And if you're like, I would not have done that, I would have just grabbed my calculator. Sorry, I had to get it out of my bag. Then that's fair too. So we would hit the math button and go up, up. Log base 2 of 1 is 0. So you could do it that way as well. So 1 is less than 0. That's false. And so we know that this point right here is false. And so these points over here are true. Okay. All right, now we're going to go ahead and move on to systems of inequalities. So a system of inequalities just means that you have, you know, 2 or more inequalities. And a system of inequalities is almost always solved graphically. I have never seen a system of inequalities solved algebraically, meaning I've never seen somebody solve it by like doing elimination or substitution or something like that. They always do it visually because inequalities are very visual graphs. And their solutions are very visual. They're not something that we could easily write the solution. And so when we solve a system of inequalities, we're going to do it graphically. It's the intersection of shaded regions of 2 or more inequalities. So I always call this the double shade, but it's also the intersection of 2 or more solid lines. So a lot of people forget that we are still curious to know where the lines cross, but we have to be careful. We can't use dotted lines anymore. They have to be solid lines crossing, and we're going to look at where 2 shaded regions intersect. So solutions should satisfy all inequalities in the system, or in this case, you know, it's going to be 2, because I think we're only dealing... Oh, there's 3 on that one. So I think for the most part, we're only going to have 2, but we might have 3. So, but the solutions you have, they should be true for each inequality in the system. Okay, so we're going to go ahead and do a couple examples of this. So we have x plus 2y is less than or equal to 4. And so the first thing I'm going to do, I don't even need this inequality. I'm just going to get this ready to graph. So I have 2y is negative x plus 4. I just subtracted the x over to the right side. And then I'll divide by the 2. So y is negative 1/2 x plus 2. So there's 2, down 1, right 2, down 1, right 2. I'll go the other direction. And based on the symbol, this is going to be a solid line. Oh, that's not very straight. That's better-ish. Okay. And then I'm going to figure out my shading. So I'll go ahead and use the point 0, 0 because that's right here. So 0 plus 2 times 0 is less than or equal to 4. 0 is less than or equal to 4, and that is true. Okay, so for this line, there's my shading. Okay, and I'm going to go ahead and graph my other line. Y is greater than or equal to x minus 3, so I'll start at a y-intercept of negative 3. And I have a slope of 1, so up 1, right 1, up 1, right 1, up 1, right 1. And it says greater than or equal to, so that means we've got a solid line. And the point 0, 0 is going to work again, and so I'll use 0, 0 for this one as well. 0 for y is greater than or equal to 0 for x minus 3. 0 is greater than or equal to negative 3, which is true. 0 is greater than a negative number. And so for this line right here, I can shade to the left of the line or to the right of the line, and 0 is to the left of the line, so I'm going to shade there. And so what just happened is we ended up with 2 shaded regions, and one of them is a double shaded region. And this double shaded region is the solution excuse me, to the system of inequalities. So I'm going to make this darker, and anytime you're doing this where you're drawing answers out for me, like in a testing situation, I need you to do this step. So that it's very clear that you are showing me where the solutions are. So I'm drawing this nice and dark. Okay, now the solutions are this double shaded region, as well as this point right here, whatever decimals are where these two lines intersect. That double shaded region, and then any points that are on this solid line, any points that are on this solid line, because our double shaded region is bounded, has boundaries of solid lines, those solid lines are part of that double shaded region. And so anything on these solid lines, where these solid lines cross, all of this is part of your solution. So this picture represents all of the solutions to the system of linear inequalities, but if they wanted a specific solution, then you could say, oh, a specific solution is negative 4, 1. Another specific solution would be 0, 2. Another specific solution would be negative 3, negative 5. If they said, hey, is the point 4, 0 a solution, you would say no. That's not in the shaded region, the double shaded region. If they said, is 0, 3 a solution, you'd say no, it's not in the double shaded region. Okay, let's go ahead and try the next one. So this one gives you two inequalities to graph, and they're non-linear. So the first one is a circle, and the center of the circle is at 0, 0. And the radius of the circle is 4. Square root of 16 is 4. Okay, so I'm going to go out 4 in all directions. And because this says less than or equal to, I'm going to draw the curve with a solid line. Oh gosh. My circle looks terrible. I'm sorry, you guys. I'm trying here. That's okay. Yeah, that's fine. Okay. So I need to figure out where to shade. I can plug in 0, 0. So 0 squared plus 0 squared is less than or equal to 16. 0 is less than or equal to 16 is a true statement. And so I'm going to do the shading on the inside of the circle. And whenever I do a system of inequalities, I always do the first inequality and then shade, and then do the second inequality and shade. If you try to graph both of them, just the curve or just the line first and then go back and do the shading, it can be very confusing. And it can also be beneficial to use 2 different colored pens, because then you can see where the 2 different colors overlap. So it's up to you. But I think that you should, graph the equation or graph the inequality first and then do the shading, because that's helpful. Okay, the next one is an exponential function. And so exponential functions are 0, 1, 1, comma, the base, and then a horizontal asymptote of y equals 0. And so in this case, we have an exponential function with the base of 2. So we're going to have 0, 1, 1, 2, y equals 0. So we're going to have a horizontal asymptote at 0, the point 0, 1, and then the point 1, 2, and then this is going to be a dotted line. So okay, and here 0, 0 is beneath the line. I'll go ahead and use 0, 0. So 0 is greater than 2 to the 0. 0 is greater than 1 is false. So 0, 0 is on the underside of the curve, and so we're going to shade above the curve. And so the part that is double shaded is right here. So this problem is a little different from the last one, because the last one had 2 lines that were solid, and this one does not. This one only has 1 solid line. So your solutions are, they're going to be in the double shaded region, but they're not going to be here where the 2 lines intersect, because we have a dotted line. It's not going to be here, the other point where the 2 lines intersect. That's a dotted line. None of these points on this dotted line are solutions. However, all of the points on this part of the solid line, these are all solutions to the system. These points are not. They're not on the double shade. So these are solutions. All the points inside the double shade are solutions. These are not solutions. These are not solutions. Okay, so if they wanted specific solutions, I could say the point like negative 1, 2, negative 2, 3, 0, 4 is a solution. Negative 4, 0 is probably not a solution, because I think this graph is above, it's on the asymptote, so this graph would have cut off negative 4, 0 from being a solution, but you get the idea. Okay, one last problem. We have 2 linear inequalities and then one that's a parabola. So I'm going to go ahead and do the parabola first. So we know that the points for a parabola are negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So I'm going to graph those points. And this is a dotted because it says greater than, so it should not be solid. The parabola should be dotted. I'm going to carry it all the way up here. Okay, I cannot plug in 0, 0, cannot plug in 1, 1. I'm going to plug in 5, 2. So 2 for y, 5 for x, 2 is greater than 25, definitely false. Okay, so the double, or not the double shade, but the shading I'm going to do so far is inside the parabola. Okay? And then I have two straight lines. So the first one is starting at positive 6 and has a slope of positive 1. And this is a dotted line. And for this one, I can use the point 0, 0. So 0 is less than 0 plus 6. 0 is less than 6 is true. So we have the line. 0, 0 is right here below the line. So here's my shading. So right now my double shaded area is inside the parabola but below the dotted line. So anytime I'm going to do 3, I always try to keep track as I go of where that double shade is going to be. And then my final answer is going to be the triple shaded region, so I'm going to have to mentally keep track of that too. Okay, start at y-intercept of 6 and do a slope of -1. That's going to be a dotted line as well. And then, so this is the line that I'm looking at, and I'm going to go ahead and plug in 0, which is below the line. 0 is less than -0 plus 6. 0 is less than 6, so still true. Both of those were true. So if this is the line right there and 0 is right here, I'm going to shade on this side of the line. And so the part that I shaded all 3 times is inside the parabola but underneath each of the lines. So it's right in here. And this time, just trying to get right up to the edge of that parabola. This time, since all of our lines are dotted, the parabola's dotted, the straight line's dotted, the straight line's dotted, that means that the triple shaded region is the only place where our solutions are. This is not a solution. This is not a solution. This is not a solution. None of these points are solutions. None of these points are solutions. No solutions here, no solutions there. The only solutions are in the shaded region because dotted lines cannot have solutions. So if they wanted to know specific solutions, I could say the point like 0, 4. I could say 1, 2, 1, 3. I could not say 0, 6. I could not say -2, 4. Those are not solutions.